Welcome back everyone to part 3 on our discussion of object-oriented programming. In this lecture, we're going to specifically focus on inheritance and polymorphism. And inheritance is basically a way to form new classes using classes that have already been defined. Let's jump to a Jupyter Notebook and see how this works. Okay, so let's begin by talking about inheritance. And as we just mentioned, it's a way to form new classes using classes that have already been defined. And really important benefits of inheritance are the ability to reuse code that you've already worked on and to reduce the complexity of a program. So we'll start off by creating what's called a base class. So this base class is going to be called animal, and it's going to be a very simple class. In fact, its init method isn't actually going to take in any arguments. Instead, all it's going to do is print animal created. So we have a very simple class here. So for instance, if I made an instance of animal, it would just print out animal created because this init method gets automatically executed when you actually create an animal. Let's add on two more methods, one called who am I? And all this is going to do is print out I am an animal. And we'll have another method here called eat. And this is going to print out I am eating. Okay, so we can see that if we have an animal here, we can do dot tab and we can ask it to eat. So open close parentheses to actually execute eating and see print out I am eating. And the other one was who am I? And it'll report back I am an animal. This is going to serve as our base class. So newly formed classes can use the animal class in order to inherit some of its methods that you may want to use again. So for example, if I want to create another instance of the dog class, or actually recreate the dog class. So I'm going to recreate the dog class, but I start thinking, hey, a lot of the features and methods of my animal class are useful to a dog. For instance, dogs, they like to eat, so maybe I want to reuse some of my prior work in my new class. The way I can do that is by inheriting the base class, this animal class. So I'm going to pass in animal here. Before we weren't passing anything, but now if I pass an animal, I'm going to inherit or derive from this base class. So this is now known as a derived class because I'm deriving some of my features from this base class of animal. So I'm going to say dog inherits animal, and then in my init call, what I'm going to do is call animal dot underscore underscore init underscore underscore self. So I'm going to actually create an instance of the animal class when I create an instance of my dog class. And I'm able to do that because I'm inheriting from the animal class. And what I'm also going to do is print out dog created. So let me run that, and I'm running that with Alt-Enter so I can get a cell right below. So I have my base class of animal, and then I have my other class of dog, which is now going to inherit the methods of the animal because inside my init method, I called animal.initMethod self. So now let's see this in action. I'm going to say my dog is equal to dog. And I run this, and now I see that an animal is created because when I run this line of dog, this init method gets called, which in turn runs the init method off animal, which in turn prints out animal created. And then after that's created, I print out dog created. But here's where it gets interesting. All those old methods that were available for the animal, who am I and eat, are now available for my dog. So even though inside this dog class, I don't have eat or who am I defined, I'm still able to use them because I was able to derive them from my base class of animal. And that's the main idea behind inheritance. I can now reuse methods that should be common between classes by just inheriting. So I don't need to rewrite all these methods for my new class. Now you may be wondering, well, what if I want to overwrite one of the older methods? Well, that's actually no problem. All you need to do is say def in your new class, and then just make sure to use the same name as the old class method, such as who am I. And now, instead of saying I am an animal, we're going to print out I am a dog. So rerun this to make sure we've redefined it. Rerun my dog, and it still says animal created, dog created. I can still call eat, but now when I call my dog, who am I? It says I am a dog. Before, it would have said I am an animal. So let's test that theory. I'm going to delete this, who am I? Rerun this. We'll create our dog again. Animal created, dog created, eat. And if I say who am I, notice I didn't overwrite it this time. It'll just say I am an animal. So you're able to overwrite the previous methods of your base class in case you need to. You're also able to add on methods. So, we're going to say def bark self, and then print out woof, so we can add methods and we can overwrite. So let me copy this eat method here and paste it in. And now I'm going to say I am a dog and eating. So I run this again. I recreate the instance of my dog here, animal created, dog created. And now if I call eat, it says I am a dog and eating because I overwrote the original method. I can still call who am I because I inherited from that base class, and it says I am an animal because I no longer overwrote it here. You can add in the method again call and then rerun this. But now I also have bark. So I could say my dog, bark, and it will print out woof. The main ideas here is that all you need to do is inherit from your base class, and now you have access to all these old methods that you wanted. And if you ever want to overwrite them, you can just overwrite them as so, recall that same method name, and then do whatever you want there, and you can always add in more methods. So that's how inheritance works, and let's move on to discussing polymorphism. So we just learned that while functions can take in different arguments, methods belong to the objects they act on. Let's finish this lecture by talking about polymorphism. In Python, polymorphism refers to the way in which different object classes can share the same method name. And then those methods can be called from the same place even though a variety of different objects might be passed in. The best way to explain this is through an example. I'm going to create two new classes. I'm going to redefine my dog class, and then I'll also create a similar cat class. We'll say def init, and the dog just takes in a name, so you can name your dog. So we assign the dog's name attribute to the name that's passed in, and then the dog is going to be able to speak. And in this case, when it speaks, it's just going to return its own name, so self.name, plus we'll say says woof. So when the dog actually speaks, it reports back whatever name you assigned it, and then says woof. And I'm going to copy this, make sure I run this cell, and right below it, I'm going to create a very similar cat class. Same deal if it's init method, you provide it a name, but instead of speaking says woof, we're going to say speak says meow. So almost the same class, except the cat says meow and the dog says woof. Okay, so I'm going to zoom out so we can see a little more of our code. We've defined the dog class and the cat class. Now let's create two instances of them. We'll say Nico is a dog with the name Nico, and we'll say Felix is the variable name for cat with the string name Felix. So I'm going to print out what happens when Nico speaks. So Nico says woof. Looks like I forgot a space here, so let's clean that up a little bit. Rerun these two cells. Nico says woof, nice. We have a little space there. And then have Felix also speak. Notice here I'm actually executing speak with open close parentheses, and Felix says meow. So here we have a dog class and a cat class. Each of them has the speak method. When called, each object's speak method returns a result that's unique to the object. That is to say, it's unique for the dog to say woof, and it's unique to the cat to say meow, as well as their names are going to be unique to that particular instance of the class. Now there's a few different ways to demonstrate polymorphism. One of them that's pretty simple is with a for loop. So I can say for pet class in, and now I'm going to say Nico and Felix. And what I'm going to do is I'm going to iterate through this list of items. And I want you to notice something here. I'm going to say print the type of pet class. And in fact, I'm just going to say pet, so that way I don't confuse you. So say for every pet in this list, print what type of pet it is. So what type of class it is, and then also print what happens when you say pet.speak. So I run this, and this is an example of polymorphism. So both Nico and Felix share the same method name called speak. However, they are different types here. So notice we have main dog and then main cat. And let me remove this type call. They're both returning a string, but it then should be noted that one of them is saying wolf and one of them is saying meow. So another way to show this, besides iteration, is through a function. And this is probably the more common way to see it being used. And I can say def pet speak. So this takes in some pet. It doesn't really care if it's a dog or a cat, because what it's going to do inside of the function is just take that pet object and then call it to speak. So notice when I say Nico pet speak, it says Nico says wolf. And if I were to pass in Felix to pet speak, it would say Felix says meow. So pet speak itself doesn't actually know whether you're going to pass in a dog or a cat. Remember, these are two different classes, and they are pretty similar in our case, but they could technically be wildly different. Dog could have 100 methods, cat could just have these 2 methods, but they share the same method name speak, which means I can leverage that capability by happening to either iterate through a list of these different classes and happen to call the same method name, or most likely I pass it into some function where later on it calls that method called speak. So in both cases, we're able to pass in different objects and we obtain object-specific results from the same mechanism, that same method call. Now, a more common practice is to use abstract classes and inheritance. And what an abstract class is one that never expects to be instantiated. You never actually expect to create an instance of this class. Instead, it's just designed to basically only serve as a base class. So we're going to say the animal class again. And the animal class is going to have an init method that takes in self name. This is the constructor of the class. And we're going to assign animals the attribute name based off what's passed in. And then this base class is going to have speak. However, later on in our code, we never actually expect to say something like my animal is equal to an instance of animal. In fact, this animal class is never actually expected to be instantiated. I don't expect to ever make an instance of the animal class. Instead, this is basically to be only used as a base class. So this speak method, and this is really common with polymorphism as you get into more advanced object-oriented programming, what we're going to do is raise an error. And we're going to learn about errors and exceptions in the next section of the course. But essentially what's going to do is say, hey, we have some sort of error here. So we'll say not implemented error. And we'll say subclass must implement this abstract method. So we run this, and what's going to happen is if we actually create an instance of animal, something which we're not expecting to do, so we'll say Fred is the name of this animal. If I say animal speak, I get back, hey, not implemented error. And this is actually telling me, hey, you're supposed to use a subclass to implement this abstract method. So the reason this is an abstract method is because in the base class itself, it doesn't actually do anything. It's expecting you to inherit the animal class and then overwrite the speak method. So I could delete this line because, as we just said, we never actually expect to use animal in that fashion. Instead, what we expect you to do is call dog and then pass in animal as you construct this dog class. And now you no longer need to have this sort of init method here. Instead, what you can do is say def speak self and then return self.name plus says wolf. And we'll do the exact same thing for cat. So I'm going to copy and paste this. And then instead of saying dog, we'll say cat there. And instead of saying wolf, we'll say meow. Run that. I will say Fido is equal to a dog with the name Fido. and I will say Isis is an instance of cat with the name Isis. And now I can print out Fido speak. And now I can print out as well Isis speak, where Isis says meow. Okay, so some real life examples of polymorphism, since these are really basic examples of using the same method name and then also having these abstract methods, is maybe opening different file types. So you may want to have the method name called open, which makes sense. You're going to open a file. But there's lots of actually different files. There's Word files, PDF files, and Excel files. And if you were trying to make a class that could be a base class for opening files, and then you have other classes that would inherit that, maybe a class for opening CSVs, another class for opening Excels, another class for opening Word files, you'd want them to be able to share the same method name, the .open name. So that's a more realistic example, and that's an example of polymorphism, where you can have some function, maybe a general open file function, can take in any of those classes that you have and just call .open on them. And it's up to the class itself to decide what actual type of file is being opened. Okay, so that's polymorphism. Basic idea is you have these two separate classes that happen to share the same method name, allowing you to then call those same method names without needing to worry about the specific class that's being passed in. We'll finish off our entire discussion of object-oriented programming in the next lecture, where we finally go over special methods. We'll see you there.